Hi, in this video we're going to talk about the transform and randomization options of the MultiCloner. Here I have a landscape object over which I want to distribute this tree. So I'm going to set my landscape as my distribution geometry, and I'm going to parent the tree to the MultiCloner. By default, as usual, I get points. I would have to uncheck the points to actually see the geometry displayed like so. The first thing I'm going to do is reduce the size of the tree, so I'll just go like this, and now we have. But the trees are actually taking the orientation of the ground, which in this case is very wavy. We would like the trees to be standing upright more than this, so the solution to that is very easy. You go down to transform and you increase the verticalized value. So whenever you do that, the trees are going to get more vertical until you reach the value of 1 where they are perfectly vertical. So I would actually reduce this a little bit, say to 0.9, just to keep some angle to the trees. If I go to my top view, here I see that the trees are not evenly spaced. To observe the even spacing, I would go back and display the clones as points. We talked in a previous video about even spacing. So here I'm just gonna increase the even spacing. Now I reached the maximum. I would like to have more than 9,999. And to do that, it's very easy. You can either type in a bigger value, or if you want to use the slider like I do, I would just increase the multiplier from over here, and then I would actually increase this value with the slider. So this is multiplying this value to come up with the search distance. So if I go like this, I would see that some tree points or some clone points are flying above the geometry. To fix that, you just snap to distribution geometry, and now the clones are on the distribution geometry, and fixing the search distance will give you the proper distribution like so. So now you can go to uncheck display points, and you see that the trees are now evenly spaced between each other. So we have a nice forest environment here. Okay, going down, the second parameter is the up vector xyz. You can change it to change the up vector. In most cases, you won't need to do that. If I choose distribute on points or on polygons, look at the orientation of the cubes. So here I'm going to increase the size just a little bit. So this is the orientation of the cubes they have. And I see that they are actually oriented towards the side poles. So if I wanted the cubes to have a different orientation or a different up vector, I'd go down to up vector xyz, and I would change the up vector to y, and that's the result that I would get. Changing it to z will give you something similar to the x orientation. So this is up vector xyz, 0, 1, and 2. So in this case, the up vector of y is giving me the best orientation, but in the case of a tree, it won't really be that visible. So I'm gonna delete these objects and go back to the forest that I have over here. So scrolling down, we have the position offset. If I change that, I'm actually gonna move the trees along their oriented x-axis. If I increase it in y, they're gonna go up, but notice that if I reduce the verticalize and I increase in y, they're gonna go in their respective directions. And the same would go to the z-axis. So this is just an offset in the position in case you wanted to do that. The rotation offset will rotate the trees globally. This is useful whenever I have a cloned object that has the wrong orientation to start with. Then you would actually change the orientation offset from here. Okay, now the randomization, it's important, but maybe the most important factor is the randomize or turbulized rotation in y. That's why by default it has a value. So if I increase the turbulization in X, they're going to have different positions in X. Usually I would go with a small value. Y in this case is not useful because they're going to change their position and fly away from the distribution geometry. But in case I wanted to do that, maybe for some animation effects, I can do it. So here I'm planting the trees one at a time. And the more randomness you actually add here at the beginning, the more versatile is the motion of the trees. So there's the position and turbulized position. Let's remove the animation from here. The turbulized rotation will change the turbulence of the rotation in X. Y is very important, and Z is another turbulization option for the rotation. Now for the size, I can just turbularize the size to give them different sizes. Now to actually see a better representation of this, I remove the even spacing just to make things go a bit faster. I'll increase the clone count and I'll reduce the clone size, say to 0.1. So now this is what I have. If I remove the turbulized size, all the trees are going to have the same size. To see this in more real time, I'm going to uncheck the leaves for the tree and maybe set the viewport levels to 2. So if I increase that value, I will see that the size is going to change, but it's changing according to a noise pattern. So here, if I increase that value for the turbulence scale, I see that at one side or one region, the size is larger than another region. And if I wanted to change that, all I have to do is change the turbulence phase, and this will actually give me the different pattern for the size change. The size is always in X, Y, Z. I can, if I wanted to, restrict the scaling to Y, and this will just scale the trees in the Y axis. It's not very realistic to do that for a tree, but for grass it would actually work. But for trees, it's not a good solution to do it because this will stretch out the branch radius. Alright, so here you can also choose absolute size so that no sizes will go down to 0. This is the turbulization of the size. In the next video, I'm going to discuss the distribute on curve.